Fantastic. All right, we are back here at the Cisco U Theater for one more exciting session at Cisco Live Melbourne. My name is Hank Preston. I'm a principal engineer here in Learning and Certifications, and I love getting a chance to talk about fundamental topics that it doesn't matter whether you're a CCNA, a CCNP, or a CCIE, they're important. And there's no topic I think that really fits into that bucket more than device administration and device security, role-based access control. So we're going to be going into the AAA approach to role-based access control and security today. So what exactly is AAA and RBAC? So AAA stands for Authentication, Authorization, and Accounting. There are three independent and separate phases that are part of any time we try to access and administer a network device. Authentication identifies who somebody is. Doesn't matter what you're going to do. All you were trying to do with the authentication phase is make sure we know who you are. In authorization, we say, okay, given that we know who somebody is, what are they allowed to do? Right? What rights do they have? Are they an administrator? Are they just an operator? Do they have the ability to enter configuration mode or just run show commands? Right? Authorization. What are you allowed to do? And then finally, accounting is the auditing portion of this process, keeping track of what somebody did or what they tried to do. Now, AAA is all I like to consider it role-based authentication, RBAC, which brings up the question, like, what exactly is a role? A role is a way to group similar users together. So in the networking space, there's often some common roles we might have. Network administrators, network operators, or maybe even automation systems if we're starting to do kind of network automation and programmability. Each role will have certain rights and privileges assigned to it. The value of doing this at the role level is it's easier to manage. Everybody that has that role gets those same groups of permissions and privileges that are on that side. Now, we typically base our roles inside of network administration tied back to some LDAP group, most commonly something like Microsoft Active Directory. And so we would want to have an Active Directory group for network administrators. And if you're in that Active Directory group, you then are given all of the roles and rights that that group grants you. Reality is that inside of the individual system, so an iOS XE switch or an NXOS device or a Firepower firewall, the roles are actually identified locally. And so we need a way to take a role from Active Directory, a group from Active Directory, and then map that back into what the device will actually issue you the ability to do. And that's where all of these features and technologies come in. Now, device administration, things like AAA, TACACS, these protocols show up across a broad range of Cisco certifications. When I really dove in and started looking at the blueprints, it didn't surprise me that much, but we do see AAA services show up at the CCNA. We see it at the CCNP level across the different domains. So whether you're enterprise or you're security or data center, service provider, right? We have concepts related to AAA, RBAC, TACACS in all of our professional tiers. And then even at the CCIE level, enterprise infrastructure, wireless, security, service provider, and data center all have elements of AAA, TACACS, and maybe Radius, these other protocols involved. Now, what you need to know about the protocols will change as you progress from CCNA all the way up to CCIE, but it's a foundational technology that's important to truly understand no matter where you are in your network engineering journey. And so let's dive into it. Let's look at the AAA architecture as it's applied to devices for device administration. And so as we start out, we have our clients. So this would represent maybe a network administrator on their laptop. We have a network device. That's what we want to log into and access. We'll have an authentication server, something that the network device is going to communicate with using TACACS in our example. And then we have the identification server. Now, typically, the authentication server would be something like Cisco ISE. And while ISE can have the identities installed, most often it ties back to something like Microsoft Active Directory or another LDAP server to provide the actual identification. So when we get into the authentication phase, the first thing is, on the client, we attempt to log in. So I log in Hank to my network device. The network device retrieves that login request, probably via SSH from me, and then passes that along to the authentication server to say, can you verify that this is Hank? He gave me a username and password. Can you verify that this is actually Hank? The authentication server takes that information and then communicates back to the identification server to say, okay, is Hank actually identified by this username and password? The identification server will confirm, assuming I put the password in right, that yes, this was Hank. The authentication server will then say, yes, this is indeed Hank. That finishes the authentication phase on this part. We then move into the second step, authorization. Now that the network device knows that I'm Hank, it's going to go back to the authentication server and say, okay, well, what is Hank allowed to do? Right? I know it's Hank. Is he even allowed to work on this switch, this device? The authentication server will go back to the identification server and say, okay, well, what do I know about Hank? Usually that's what groups is Hank a member of in Active Directory. We get a package back, right? Here's Hank's file. The authentication server will look at that and then provide information back to the network client that identifies what Hank's allowed to do. The authentication server is typically responsible for taking the group membership and converting that to a role identity that the network device understands. In iOS, that's typically a conversion to like a privilege level. Do they get privilege 15 or do they get privilege 0 or privilege 1? Once the network device has the information back, it can then finish the authentication, like the login process from Hank, and say, hello, Hank, and we have verified who you are and what you're allowed to do. Now, once I'm logged into the device, I'm going to start doing things, and this is where accounting jumps in. I might go through and say, I want to do X. The network device says, okay, assuming Hank's allowed to do X, we will then notify the authentication server that said, hey, Hank did X. The authentication server then records that in its audit trail log. So we go through again, authentication, authorization, and accounting. 3 separate steps, and they're independent as it goes through. As a network user, right, as an administrator logging in, it feels like it's all one thing, but it's actually 3 separate steps. So let's look at how we actually enable device administration in an example. Now, this can become very sophisticated and complex depending on the number of devices, the types of devices, the platforms you might be using, the role distributions, but we're going to keep it fairly straightforward in this example. We're going to focus on Cisco IOS XE. From an authentication server perspective, we're going to use Cisco ISE and Microsoft Active Directory. We're going to use TACACS as the protocol, which is, I think, still the most common protocol we would use for device administration. Radius is an alternative option as well, but TACACS is typically what's used for device administration. And then from a roles, we'll have 2. We'll have a full read-write. We'll call that the admin role. And we'll have a read-only, an operator role that's provided as well. All right. At the device level, how do we have to configure this? There are a few steps involved. We'll start out by just setting up the client to server connectivity. In this case, the client is the network device, the switch or the router. The server would be ISE, our authentication server. We then define and group the authentication servers together. In a production environment, we don't want to have just one authentication server. If we have one server and ISE goes down, that can provide access problems to the network. We want to make sure we've got redundancy, so we'll group them in. We'll set up a fallback authentication mechanism. What happens if there is a catastrophic failure with either Active Directory or ISE? We want to make sure we don't get locked out of our network, so we'll set that up. And then finally, we'll go through all 3 of the phases. We'll configure policies for authentication, authorization, and accounting. All right, let's start out some basic setup. We log into our iOS XE device, and we will go ahead and enable AAA services. iOS has been around for a long time. We don't generally change defaults very often, and so you still may have to, on your platform, go ahead and run AAA new dash model. That fires up the actual AAA services on the device. We'll then configure our fallback account. I like to use local admin, right? Admin would work as well, and that's a common local account we might have. But by putting local admin in the name, like identifies this is a local account on the device. And I make it a privilege 15, so an administrator, and I give it a secret. I don't recommend using secure pass as your secret password, but in my example, right, it's a decent one to use. After that, I say, which interface off of this device am I going to use to communicate to the TACACS server? Now, typically on a lot of our platforms, we might have management interfaces. Or in this case, I'm using a VLAN interface to communicate back because VLAN 11 is used for out-of-band management in this environment. Now, there's a note in here. If your management interface is in a VRF, you have to identify that as well. So you would have VRF identification in the command, but I kept it pretty basic here. No VRF, just the default routing table. This is the interface we're going to use. Now, this next step is something that I've labeled as optional, which is true. This is not something you have to do to get AAA services to work, but it's something I recommend and something we do in our own environment. The idea is to set up our console connection, what we would use with that blue ribbon cable or a terminal server, to be local authentication only. The idea here is we don't typically use console access for day-to-day management. We would often use that simply when something is wrong. And if we know that something's wrong and we're trying to get access through the console port, maybe we just take the authentication ISE server out of the mix and we'll just use local authentication. So to do that, we set up some special policies, AAA Authentication and Authorization, and you can see I've got console identified here, and I'm going to say just use local mechanism. Right? I'm only going to use those local accounts that are set up. Then we go on to line console 0, and we indicate for authentication through login, we're going to use console. That ties back here. And then for authorization for exec, right, executive functions, we're going to go ahead and also use console access. This means if I have problems either while I'm setting up the ISE access at first, or even down the road if something goes wrong, I know that I can still get access to the device through the console with the local username and password. Now, maybe this is something you set up just when you're enabling AAA at first, and then you take this away when we know AAA is working. That would be fine, but definitely something that's worth doing, at least to make sure that you don't lose access. All right. Once we've got our fallback access set up, we can move forward to defining and grouping together our TACACS servers. As I mentioned, in a real environment, we don't just want one TACACS server. We want at least 2 or potentially 3 or 4, right? We want to have some redundancy in place. And so we start by identifying each one of our servers. TACACS server ISE 01. We give it the IP address that we're going to use to communicate with the server. And then we have to communicate with a secure key, or a shared secret, it's sometimes referred to. This key is used to encrypt and kind of make sure that the communication from the switch or the router to ISE isn't just in clear text. Because remember, we're going to be sending usernames and passwords to the authentication server. We don't want that just to be in clear text flowing across the network. And so we secure that using the key. With the ISE servers defined, I can then create a group of servers for TACACS Plus, called, in this case, ISE TACACS, and then server name, and we group them all together. Now that I've got my TACACS servers defined and grouped, I can start to use them in the policies for communication. And so remember, we have to configure authentication, authorization, and accounting policies separately. And so I've got AAA authentication, login, and you can see I've got default. I'm defining the default method for authenticating users in this case. On console, maybe we have a special one there, but if it's nothing specific is defined, we're going to use the default method, and we're going to start by checking with ISE TACACS, that TACACS group we created. Now, you could just stop there, but again, I like to be prepared. At some point, the ISE servers are going to go down and we'll have a problem. And so if we can't reach ISE, we will then use local credentials to allow us to still log into the devices that are there. We do a similar type of a policy for authorization. AAA authorization, exec, once again, default, group, ISE, followed by local. This will ensure that if the ISE servers are down, I can still authenticate and be authorized to work on the devices. That brings us back to the accounting section. We can see I have 3 different policies I'm configuring in iOS for accounting, and that's because there's different things that we can keep track of. This first one, AAA accounting exec default, start, stop, group ISE, will track every time we enter enable mode. So when I log into a device and I move into enable mode, it will say, okay, Hank has moved into enable mode. We track that. And then when we leave it, it would track it again, start, stop. These other ones, AAA accounting commands, and we can see 15 and 1, this will tell iOS or tell the switch in the router to say every command that Hank runs that is at privilege level 15 or privilege level 1, so this would be all our show commands plus our configuration commands, right? I want to keep track of every command that Hank runs on that. If I only do exec, I'll keep track of when Hank goes into enable mode, but I won't know what commands he ran. I need these other ones to keep track of the commands that were run as well. A few tips when you're setting up AAA services in your network. Thoroughly test on a device that you can physically touch, if at all possible, before you move to remote devices, right? It doesn't matter how many times I've set up AAA and TACACS services with ISE, with Active Directory. I've done this dozens, if not hundreds of times. Something will always go wrong, and being able to make sure that those policies, everything is set up correctly at first on a device that I can physically unplug the power from if I need to, always makes me feel a little bit better. And then have a plan for when you lock yourself out. This is something else that will probably happen any number of times when you're manipulating AAA services on your configuration. We do have options in iOS, right? We've got the reload command, which reboots a switch. We can do reload in 10 minutes. That's always a handy one as well when I'm configuring something that might cause a problem, right? Preemptively say, hey, if I don't undo this reload, just reboot the switch, remove any configuration I've done. That's handy, again, on maybe a remote lab device to have an option. And then, as mentioned, I had it as optional, but I still think it's a really good suggestion is to keep your console as local, at least until we have the configuration accurate and functioning. You can then potentially move that back to your AAA servers as well. All right, our device is now configured. Let's talk about how we set up our authentication server. In our case, that's going to be Cisco ISE. Like we had steps for configuring the devices, we've got some steps to configure this on the authentication server. First up is we want to connect to Active Directory. We're going to do that because we don't want to define the users and group membership on ISE itself. That's already done in most of our organizations in Microsoft AD or some other LDAP server. So we connect Active Directory to the AD server. We then select whatever external groups that are in Active Directory are going to be relevant for us. You might have 1,000 groups in Active Directory. Some of them are used for application access, who can access HR systems, maybe file shares. Maybe there's only 2 groups that are relevant for network administration and operation. We'll just pick those couple of groups that we need. We'll then add our devices to the inventory. Every single switch, router, firewall, server device, PDU, ISE needs to know how to talk to those, so we add them in. We'll then create the policy elements required. We'll figure out our conditions for identifying users and devices so that we can identify them to a role. We'll set up the role profiles and command sets, right? So we've got a role called network administrator. What does that mean? We do that in these policy elements. Once all the policy elements are done, we create a policy set where we pull all of these individual pieces together to identify a person on a particular device who's a member of this group gets these results. And we'll see all these things come together. All right, joining Active Directory to ISE is actually quite simple. We log into our ISE server, we go over to our external identity stores, we just hit the add button, and we would use appropriate Active Directory credentials to join ISE to the domain, just like we would join any Windows host or any other host into the domain. Fairly straightforward on that side. You will need credentials that are authorized by Active Directory to join the domain. And so if you're not the Active Directory administrator, you may have to get that from your AD administrator. We can then go in once it's in place and we can start to add new groups from the directory so that we can list them out. And we can see in here, I've got a few groups, CLL.cloud, CLL team, and then CPNR super admin. I've got CLL team, network devices read only, network devices super admin. These are Active Directory defined groups that I want to keep track of, that I'm interested in. Those are the only ones that we'll pay attention to on that side. Once Active Directory has been added into ISE, now we can go ahead and add all of the individual devices to the inventory as well. We have a couple of options on how we might do that. We can see if you're only doing one device, you can just hit the add button and you'll get a nice GUI where you can go through and say, here's the name of the device, here's the IP of the device, here's the type that it is, like all the things we need to know to add the device. If you're doing more than one device, maybe you're trying to bulk load them all, I highly recommend using the import mechanism. The import mechanism will give you an ability to download a sample spreadsheet that you fill in with the device names, IP addresses, shared secrets, device types, all of that information that's relevant, and then you can simply import that spreadsheet back into ISE. Super easy to bulk manipulate what those devices are. Highly recommend what those are. Now, ICE does let you say, okay, I want to add a device, and then rather than putting in a /32 host IP address, you put in a /24, an entire subnet. And then what that does is it's kind of nice, it's easy, right? Any device coming from that IP address range would then be allowed to communicate, assuming it has the proper shared secret. That's less work to set up, but we lose a lot of granularity about knowing from a reporting perspective who's connecting, right? If we have a shared secret problem or a device becomes compromised, right, it can impact an entire subnet full of devices. So I definitely recommend use specific IP addresses when adding devices into ICE rather than full ranges that are there. You also have options to identify things like the location of a device. In our case, we actually identify location in the data center based on the rack the device is in, what type of device it is. We go down to the part numbers that are in place. The more specific you can be on location and type, the better your policies can be. Location may not be as important, but device type could be really important. The policies that we apply down to an iOS device are very different than the policies we apply to a Nexus switch or a Firepower device. We have to be able to distinguish them, and that type field is really important for that. Here's a view at what the details are for a device. In this example, we can see that this was a Catalyst 3850. Its location was in rack B23. This is an out-of-band management device. Ignore the fact that it says it's a firewall. That's a remnant from some old configuration in ICE, right? And we can see what tenant it's in. All of these things are useful for me to be able to then build policies around it. Speaking of policies, we'll go ahead and create some of those. Now we need policies to actually identify users and devices. Again, our users are going to be identified based on the group membership that's there. So we can see I have a policy here that says, okay, if someone comes in and their group equals network devices super admin, then that's the condition. I'm going to use that to match users based on that group. Down here, I can see I have a condition called iOS XE based network devices. And then I say, okay, well, if the device type matches any of these different platforms that represent different switches and routers that run iOS XE, they all match that condition. What's really nice about building these conditions, they're reusable. And so I have a policy that now matches all iOS XE devices that I can use. When I add maybe a new model of Catalyst 9000 switch into our environment, I don't have to update individual policies. I simply can update this condition, and any place that condition is used will be applied. So it trickles down, right? Very helpful on that side. So you don't miss one policy someplace buried out. Role profiles are how we say, okay, these are the rights that somebody might get in a role. And so for iOS XE, right, we'll come through here and say, okay, I've got a role profile for iOS XE admin. These are where the TACACS information for that platform comes through. And we can see that I'm setting the default privilege and the maximum privilege to 15, which is the highest privilege on an iOS E device, Priv 15. And then I always like to look at the raw view to see what actually gets sent down to the device. And we can see they just get sent as key value pairs. Priv level equals 15, max priv level equals 15, and that gets pushed through. You will need a policy element like this for each of the platforms. If we look here, we can see in my setup, I've got iOS XE admin and operator. Admin's privilege 15, operator will be privilege 1. Right? I've got Firepower chassis admin and operator, NSO admin and operator, NXOS admin and operator. Each of those platforms have different syntax required to identify what the roles are. And so I need policy elements for every single platform that we're supporting. Right? So, and once you build one, the way we build them might be very similar, but the specific name that the role has for Firepower is probably a little different than the role from an NXOS device. And so you'll end up with a series of policy elements, or role profiles. The other thing you might want to do, and this isn't necessarily required to be super specific, but in addition to assigning a global role like privilege 15, you can do more customization on that and say, okay, well, they get this privilege level, but I want to limit maybe what commands this person's allowed to run. So this is beyond what we're going to go super in depth in this session, but iOS or TACACS and ICE does support saying, okay, this user is this privilege and they're allowed these commands, but not these commands. So you can support that if you need a much more sophisticated type of a setup. Once all of the pieces are done, our conditions for users, our conditions for devices, our policy elements, then we start to create the policy set where we bring these things together. And we can see in my policy set here, I have policy sets for PDUs, NSO, UCS, FXOS, iOS, and XE. So again, all of those platforms have different combinations that come together. I identify the users. I identify all the pieces that go in. If we break down and we look at just the policy set for iOS here, we can see, okay, I'm going to say I'm matching for iOS XE everything that is an iOS XE based network device. We saw that policy element a moment ago. It listed all of the type platforms that I had. So if I match one of those and I'm going to authenticate users based on Active Directory, and then down here at authorization, we can see I've got two different conditions. If they match the network admins, again, that matches back to the Active Directory group, then I'm going to assign the iOS XE admin command set and shell profile. That's where the privilege stuff comes in. However, if they're not in the admins group, but they're in the read-only group, the operator group from Active Directory, then I will give them the operator role and the operator command sets. If I'm not in either one of those conditions, I would get the default, which results in a deny. That's an interesting one and kind of highlights the difference between authentication and authorization. Up here, I authenticate a user. Maybe I authenticate one of our, I don't know, HR people somehow gets a chance to kind of like tries to log into a switch someplace. Active Directory knows who they are, but when we go into the authorization phase, they're not a member of either of the network related groups. And so they still will hit this default policy to say deny everything. Authentication, they passed. Authorization, they failed. Two separate steps on that side. All right, with all of these pieces pulled together, let's see what this would look like in action. So we'll start out with our first two A's. Once again, authentication and authorization. I'm over here and I'm trying to log into one of my switches, right? So this is a switch that all my PDUs in the data center connect into. So I provide my username and my password. We go into the logs from ISE and I can see those two phases. I can see the authentication happened here and it matched iOS XE default. Immediately after authentication, we then go into the authorization phase. The switch now knows who I am, but we need to know what is Hank allowed to do. And authorization sent back the shell profile iOS XE admin because I happen to be in the administrative group in Active Directory. Right, I've got those in place. I can see details by clicking on the little detail button that's over here, which will give me the ability to see all that information. Authentication passed, return the replies. All of these pieces are in place. Here's the authorization side where I can see the authorization reply included privilege level 15, right? So AAA authentication, authorization are done. We then can go into the accounting logs in ISE and start to see the other pieces, right? I can see start when I connected to a device. Now, I connected to a device and was immediately put into enable mode. That's why it went right to start. When I disconnect from a device, I get a stop message. So it tracks all of those things in ISE for me so I can see what's there. And then down here, if I go into the command accounting, I can see every command that's run by the users on the device. Very helpful, right? It's not that I want to be able to go back and blame a user when it goes in, but it's really important to be able to track what happened if something does go wrong. So having that command level authenticate or accounting is really important. Now, as we come to the end on this one, that's what we could see from the ISE perspective. There's also show commands available on the devices themselves. A simple show TACACS will show you whether the network devices are able to communicate with the authentication server. In this case, I can see it's alive. That's a good thing. And then I also have show AAA user all, and I can see kind of records about users as they're connecting and what type of messages are happening, right? A way to debug and see what's in place. All right. With that done, right, we're coming down to the end on this side. Some final thoughts. Radius and TACACS can be used for lots of different vendors from lots of different devices, right? As network engineers, we primarily think about and focus on switches and routers, but even from Cisco, our compute platforms, UCS, right, our firewall platforms, ASA, as well as Firepower, they all support these things. You get outside of Cisco and you can find TACACS support on PDUs. You saw I had references to those as well. We use TACACS to authenticate our PDUs for administration. You can find it on KVM traffic. You can find it on all sorts of different platforms that are there. Another thing to remember, it's much easier to set up AAA services on a network and device before it's in production, right? Because as I mentioned, you're likely to make a mistake, things might go wrong. It's easier to do that before you're actually counting on that switch or router to pass production traffic. So try to do your AAA services up front. The other idea here is that I hear from a lot of companies, particularly small shops, that, hey, everybody that connects to our network, they're an administrator, right? Why do we have to give individual accounts? We don't have different roles. Maybe that's the case. And again, not that we want to blame folks, but it's important to have a little bit of accountability, right? Know who's logging in. Also, there's this problem. What happens when someone leaves? If everybody logs in with admin and then admin123, the super secure password, when that person leaves, right, they remember admin and admin123, and now maybe you have to change that, and if that account is used by all your management tools and systems as well, can have a lot of trickle-down effect that's in place. So definitely use individual accounts, even if everybody has the same rights. There are lots of capabilities in there. Dive in, see what's possible with device administration. All right, that does bring us to the end of this 30-minute session in Cisco U, where we dove in and take a look at device administration. It's a topic that we have to learn way back at CCNA, becomes relevant all the way to expert. Every day we manage our devices. We want to make sure we can do that effectively. So dive in, become comfortable configuring and using RBAC and AAA services. If you got any questions, feel free to stay in touch with me. My contact information is up there. I also blog pretty regularly on Cisco's blog site. And in fact, fairly recently, within the last month or so, I had a blog about AAA and TACACS where I dove in and how you can actually experiment with these things using Cisco Modeling Labs, where my TACACS server in that case is not ISE, though you could have used it in Cisco Modeling Labs. I'm actually using an open source version of TACACS called TAC Plus, where you can actually experiment with that super lightweight and see how you can do TACACS device administration with all your platforms that are out there. All right, with that in mind, we're coming to the end of the session. So thank you so much for joining me for this session. We've got more sessions here in the Cisco U Theater today and tomorrow, and we're still not quite done at Cisco Live. So lots of great technical content to have added.